Hi everybody, welcome back. This is very odd because I'm sitting here looking at you and I'm going to start talking about the notes you need for the sound article right now. So first we start out, this is a crazy old picture, but you're actually seeing they had some kind of fog there and a big huge amplifier, and you can see the compressions from the sound wave that is emitted. So this part right here is a horn, and the sound waves are traveling in all directions, and it goes through the amplifier and you can see them. I just thought it was a cool picture. The basic facts you need to know about sound. Sounds are produced when anything vibrates. Even electrical frequencies make vibrations and we can hear it. Sound travels in compression waves, what we know as longitudinal waves. And here is the speed of sound, something to keep in mind because we will talk about why sound goes slower than light a little bit later. And the speed of sound is dependent upon the temperature and the humidity of air. So sound travels through mediums at different temperatures at different speeds. We know that sound waves need a medium. Sound travels faster through solids because they're more dense, but they don't travel more loudly or farther. They just go faster. And then sound does travel faster through a warm medium rather than a cold medium. Because if I have a warm brick, those particles are moving around more quickly than a cool brick. All right, wave speed can be calculated. We really won't do much with these calculations. And the speed of the wave just depends on the medium. All right, amplitude, the height of the sound wave or the crest of the sound wave is related to how loud it is. That's why amplifiers make music louder. And the human range for loudness is 0 to 120 decibels. You can be exposed to sounds that are louder, but basically it's too loud for you to hear, and it usually will cause some damage to your inner ear and possibly damage to your eardrum depending on how loud the sound is. Some people who have explosions very close to their head will have their eardrum rupture, which is particularly painful. And the iPod maximum volume is 120, and if you are exposed to decibels of 120 for long periods of time, it will result in hearing loss as you age. So the lowest sounds we have, we are, 0 0.1, that's like leaves rustling or chairs scraping across the floor, and it works its way up. So iPod maximum volume is louder than being next to a chainsaw. All right, frequency is related to the pitch. So how many wavelengths you have, if you have a really skinny short wavelength, that determines the highness or the lowness of your sound. Humans can hear wavelengths. Thank you. Humans can hear wavelengths from 20 hertz, which is the lowest low tone you could possibly imagine, up through about 20,000 hertz. But as you get older, your high and your low frequency hearing tends to fade, and that's why so many people have hearing aids. And this chart just shows you the frequency ranges of certain animals that we would know and what their ranges are. So the human range is right here. There are sounds that are lower and sounds that are higher. We just can't hear them. And that's like a dog whistle. The dogs can hear the dog whistle because it's above 20,000 hertz, but we can't hear it because it's too high for our ears. And sounds below 20 hertz are called infrasonic. Infra means below. And above 20,000 hertz are called ultrasonic, and ultra means beyond. And so this frequency is how many waves occur in a period of time. So the skinnier the wave, the higher the pitch. The longer the wave, the lower the pitch. Alrighty. And then how do compression waves look with different amplitudes and frequencies? If you want to try this, I'm hoping that I can get it to, I want to see if we can make this happen, where we can open up this web page. Oh, it says I can't open this website, but there are websites out there that let you add waves together. So I will have to open that again and do a second recording for you guys. Lastly, the Doppler effect. I know you guys have all heard this happen before. When a train or an ambulance or a car with a radio loud approaches you, I know that you've heard and experienced the change in pitch as the car approaches you and then passes you, or the train or the ambulance or whatever it is. And that's because the sound source is moving and the waves get squeezed together as the sound source approaches you. And when you have skinnier wavelengths, you have a higher frequency. And as the car passes you or the sound source passes you, the waves stretch out and the frequency gets lower. We do use sonic technology. We use ultrasounds for medicine because we measure how fast the waves bounce back and we can map out what things look like inside the body without cutting. We use ultrasonic cleaning. There's toothbrushes or jewelry cleaners that use sound waves to basically shake off dirt off of jewelry or shake the tartar right off your teeth. And then infrasonic monitoring detects earthquakes. Earthquakes do make a sound. It is really low. We can't hear it. Animals do. And when animals hear it, they freak out. So your summary is basically that sound waves are vibrations and they travel out. And we measure the pitch is the measurement is the frequency, and the loudness, sometimes called intensity, would be the amplitude. All right, I will put up another recording later when I can get this applet to run. So as soon as I get that going, I'll post another link. Thanks for watching. Bye.